Hello, this is Information Service Engineering and my name is Harald Sack.
And my name is Maria Kutraki.
This is the second lecture of the term. It's Natural Language Processing Part 2. What are we going to do in the second lecture? So we finished the last lecture with regular expressions. And regular expressions are one way to phrase so-called regular languages. Another way to represent regular languages are so-called finite state automata. And you will see that with the help of this type of construct from theoretical computer science, we are able to do analysis, for example, for morphological analysis, to find out how a word is constituted. For this, we are using an extension of the finite state automata, which are called finite state transducers.
Then we will continue with the third part of the lecture, which is called Language Model and Ngrams, where first we are going to introduce language models and especially Ngrams, and also we are going to see some of the basic components in probability theory, which we are going to use in the future tasks. So we are going to check the conditional probabilities and the joint probabilities. Then we will move to the 2.4, which is the second part of language model and Ngrams, where there we go deeper into Ngrams and introduce the notion of MLE, the maximum likelihood estimation, and check all the formulas of the different Ngrams. And last, to finish with the part of language model and Ngrams, we're going to see how we actually compute this maximum likelihood estimation for a given Ngram and some challenges we might face there, like how do we cope with unseen words in a vocabulary, or how do we cope with unseen Ngrams in a training phase. Also, we will introduce the notion of perplexity and smoothing.
And then as a last example of natural language processing, we will take care of part of speech tagging. What is part of speech tagging? In part of speech tagging, usually you try to find out what is the function of a word. Is it a noun? Is it a verb? Is it a determiner? As you might know, this does not only depend on the word itself, since a word might come in different contexts and then it might play different roles. So it might be, in the one case, it might be a noun, in the other case, it might, the same word, be a verb. Now the question is, how do we determine that? We will see that with the help of so-called hidden Markov models, we will be able to tackle that problem from a probabilistic point of view. So this is the context and the content of the second part of natural language processing and the second lecture of information service engineering. Now we will continue with the first chapter, which is finite state automata.